Firstly, open the software RAFI-T009/4SE and then go to the test part and select the type of test you will do in this experiment. For this experiment, we'll do brake test and weight test.
Logo tak ada, tension tak ada. So bila you dah pilih macam ni, you tekan,
press enter and then select the vehicle type you will use in this experiment. For this experiment, we will use car. There's no trail hitch attached to the car, so we'll skip this part.
Okay. Sekarang ni dia minta kita drive kereta kita through side slip ni.
And now we'll move the car onto the weight scale and make sure the front wheel was at the center of the weight scale. After we took the weight of the car, move the car front wheel onto the roller to do the brake test. During this procedure, make sure you grip the steering wheel tightly so the car won't go off the roller. Press the start button, let the roller run for a while before you press the brake pedal. After you press the brake pedal, the brake efficiency will be shown on the screen. And now move the car to the rear wheel to do the handbrake test. The same with the front wheel, make sure you grip the steering wheel tightly during this procedure. And next, press the start button. Slowly press the brake pedal before you pull the handbrake. Now fill the form. Write down the type of car you use and the model, and then save the form you fill just now into the database. To print the result for the test just now, go to the show name and fill in the name you put into the form just now.
Okay, pergi 4 dia suruh kita. Okay, confirm data. Yes. 4. Okay. Yang kita punya data tadi tu ada dekat sini dengan kat sini je kan. Jadi pilih yang ni dengan yang ni. Yang ni awak select. Awak unselect lah awak. Awak pergi ni enter, awak tak nak awak enter. Kalau yang mana awak nak awak enter juga. Okey. Pergi dekat sini. Bawa anak panah pergi dekat sini record ni. Okey. Ni. Okey. So kita print dua. Awak print lagi sekali boleh? So saya on printer dulu. Yes, F4.
A difference in brake force of less than 30% between the left and right wheels on a single axle is a critical safety requirement. Enforced by standards like those from Puspacom, if the difference is larger than 30%, it creates a significant braking imbalance. This imbalance will cause the vehicle to pull or swerve aggressively to the side with the stronger brake. This is extremely dangerous and can lead to a complete loss of driver control, especially during an emergency stop or on a wet, slippery surface. Adherence value, this term generally relates to the grip or effectiveness of the brakes. If we interpret adherence difference as the imbalance in brake force, a difference of more than 10%, even if still under the 30% failure limit, would create a noticeable imbalance. This would cause the vehicle to pull slightly to one side during braking over time. This imbalance will also lead to uneven wear on your brake pads, rotors and tires, requiring more frequent maintenance. While the vehicle shows excellent brake balance on both the front 77% difference and rear 5% difference axles, it failed the overall safety test. The primary issue is not brake imbalance but a lack of sufficient total braking force, as shown by the 47% efficiency reading below the 50% minimum. This means that during an emergency stop, the vehicle will take a dangerously long distance to come to a complete halt. The vehicle requires maintenance to address this issue, which could be related to worn brake pads, contaminated brake fluid, or a problem with the master cylinder. This experiment successfully evaluated the braking system of a Prodwa MyV 3rd Gen using a roller brake tester. The objectives of measuring brake force, balance, and overall efficiency were achieved. The test results showed that the vehicle has excellent brake balance on both the front axle and the rear axle, both well within the 30% safety limit. The parking brake also passed with an efficiency of 28%. However, the most critical finding was that the vehicle failed the overall service brake efficiency test. The measured efficiency was 47%, which is below the 50% minimum safety requirement. In conclusion, while the brakes are well balanced and would not pull the car to one side, the vehicle's total stopping power is insufficient and unsafe. The experiment successfully identified this critical safety flaw, demonstrating that the vehicle requires immediate maintenance to improve its braking force before it can be considered roadworthy.